The National Weather Service, once known as the Weather Bureau, is a part of the National Oceanic and Atmospheric Administration of the United States government. It is headquartered in Silver Spring, Maryland. The NWS is tasked with providing forecasts, public warnings, and other products to organizations and the public for the purposes of protection, safety, and general information. This is done through a collection of national and regional centers, and 122 local weather forecast offices. As the NWS is a government agency, most of its products are in the public domain and available free of charge. History: in 1870, the Weather Bureau of the United States was established through a joint resolution of Congress signed by President Ulysses S. Grant with a mission to provide for taking meteorological observations at the military stations in the interior of the continent and at other points in the states and territories, and for giving notice on the northern lakes and on the seacoast by magnetic telegraph and marine signals, of the approach and force of storms. The agency was placed under the Secretary of War as Congress felt military discipline would probably secure the greatest promptness, regularity, and accuracy in the required observations. Within the Department of War, it was assigned to the U.S. Army Signal Corps under Brigadier General Albert J. Meyer. General Meyer gave the National Weather Service its first name, the Division of Telegrams and Reports for the Benefit of Commerce. The agency first became a civilian enterprise in 1890, when it became part of the Department of Agriculture. It would later be moved to the Department of Commerce in 1940. The first Weather Bureau radiosonde was launched in Massachusetts in 1937, which prompted a switch from routine aircraft observation to radiosondes within 2 years. The Weather Bureau became part of the Environmental Science Services Administration when that agency was formed in August 1966. The Environmental Science Services Administration was renamed the National Oceanic and Atmospheric Administration on October 1, 1970, with the enactment of the National Environmental Policy Act. At this time, the Weather Bureau became the National Weather Service. Bob Glan has written a comprehensive history of the first 100 years of the National Weather Service. Forecast Suborganizations. The NWS, through a variety of suborganizations, issues different forecast products to users, including the general public. Although throughout history text forecasts have been the means of product dissemination, the NWS has been using more forecast products of a digital, gridded, image, or other modern format. Each of the 122 weather forecast offices send their graphical forecasts to a national server to be compiled in the National Digital Forecast Database. The NDFD is a collection of common weather observations used by organizations and the public, including precipitation amount, temperature, and cloud cover among others. In addition to viewing gridded weather data via the Internet, users can download and use the individual grids using a GRIB2 decoder, which can output data as shapefiles, netcdf, grads, float files, and comma-separated variable files. Specific points in the digital database can be accessed using an XML SOAP service. Fire weather. The National Weather Service issues many products relating to wildfires daily. For example, a fire weather forecast, for up to 7 days, is issued by local weather forecast offices daily, with updates as needed. The forecasts contain weather information relevant to fire control and smoke management for the next 48 hours, such as wind direction and speed, and precipitation. The appropriate crews use this information to plan for staffing and equipment levels, the ability to do scheduled controlled burns, and assess the daily fire danger. Once per day, NWS meteorologists issue a coded fire weather forecast for specific USFS observation sites that are then input into the National Fire Danger Rating System. This computer model outputs the daily fire danger that is then conveyed to the public in one of 5 ratings: low, moderate, high, very high, or extreme. The local weather offices of the NWS also, under a prescribed set of criteria, issue fire weather watches and red flag warnings as needed. In addition to issuing the daily fire weather forecasts for the local service area, these products alert the public and other agencies to conditions which create the potential for extreme fires. On the national level, the NWS Storm Prediction Center issues fire weather analyses for days 1 and 2 that provide supportive information to the local WFO forecasts regarding particular critical elements of fire weather conditions. These include large-scale areas that may experience critical fire weather conditions, including the occurrence of dry thunderstorms. These are thunderstorms, usually occurring in the western U.S., that are not accompanied by any rain due to it evaporating before reaching the surface. State and federal forestry officials sometimes request a forecast from a WFO for a specific location called a spot forecast. Spot forecasts are used to determine whether it will be safe to ignite a prescribed burn and how to situate crews during the controlling phase. Officials send in a request, usually during the early morning, containing the position coordinates of the proposed burn, the ignition time, and other pertinent information. The WFO composes a short-term fire weather forecast for the location and sends it back to the officials, usually within an hour of receiving the request. The NWS assists officials at the scene of large wildfires or other disasters, including HAZMAT incidents, by providing on-site support through incident meteorologists. IMETs are NWS forecasters specially trained to work with incident management teams during severe wildfire outbreaks or other disasters requiring on-site weather support. IMETs travel quickly to the incident site and then assemble a mobile weather center capable of providing continuous meteorological support for the duration of the incident. The kit includes a cell phone, a laptop computer, and communications equipment, used for gathering and displaying weather data such as satellite imagery or numerical forecast model output. Remote weather stations are also used to gather specific data for the point of interest. They often receive direct support from the local WFO during such crises. IMETs can be deployed anywhere a disaster strikes and must be capable of working long hours for weeks at a time in remote locations under rough conditions. There are approximately 70 to 80 IMETs nationally. Weather forecast offices. The National Weather Service uses local branches, known as weather forecast offices or WFOs, to issue products specific to those areas. Some of the products that are only issued by the WFOs are severe thunderstorm and tornado warnings, flood, flash flood, and winter weather watches and warnings, some aviation products, and local forecast grids. The forecast products issued by a WFO are available on the website. National Centers for Environmental Prediction. Aviation. The NWS supports the aviation community through the production of several forecast products. Each area's WFO has responsibility for the issuance of terminal aerodrome forecasts for airports in their jurisdiction. TAFs are concise, coded 24-hour forecasts for a specific airport, issued every 6 hours with amendments as needed. As opposed to a public weather forecast, a TAF only addresses weather elements critical to aviation. These include wind, visibility, cloud cover, and wind shear. 21 NWS Center Weather Service units are collocated with the Federal Aviation Administration Air Route Traffic Control Centers. Their main responsibility is to provide up-to-the-minute weather information and briefings to the traffic management units and control room supervisors. Special emphasis is given to weather conditions that could be hazardous to aviation or impede the flow of air traffic in the national airspace system. Besides scheduled and unscheduled briefings for decision-makers in the ARTCC and other FAA facilities, CWSU meteorologists also issue 2 unscheduled products. The Center Weather Advisory is an aviation weather warning for thunderstorms, icing, turbulence, and low cloud ceilings and visibilities. The Meteorological Impact Statement is a 2 to 12-hour forecast for weather conditions which are expected to impact ARTCC operations. The Aviation Weather Center, located in Kansas City, Missouri, is a central aviation support facility operated by the National Weather Service. The AWC issues 2 primary products: airmet information on icing, turbulence, mountain obscuration, low-level wind shear, IMC conditions, and strong surface winds. SIGMETs, issued for significant weather that may affect an airport or flight path in an area, Convective issued for an area of thunderstorms affecting an area of 3,000 square miles or greater, a line of thunderstorms at least 60 mi long, and or severe or embedded thunderstorms affecting any area that are expected to last 30 minutes or longer. Non-convective, issued for severe turbulence over a 3,000 square miles area, severe icing over a 3,000 square miles, or IMC conditions over a 3,000 square miles area due to dust, sand, or volcanic ash. Storm Prediction Center. The Storm Prediction Center in Norman, Oklahoma issues severe thunderstorm and tornado watches in cooperation with local WFOs and also issues mesoscale discussions focused upon possible convective activity. The SPC compiles reports of severe hail, wind, or tornadoes issued by local WFOs each day and formats the data into text and graphical products. The SPC is also responsible for issuing fire weather outlooks, which support local WFOs in the determination of the need for red flag warnings. Weather Prediction Center. The Weather Prediction Center in College Park, Maryland provides guidance for future precipitation amounts and areas where excessive rainfall is likely, while local NWS offices are responsible for issuing flood watches, flash flood watches, flood warnings, flash flood warnings, and flood advisories for their local county warning area, as well as the official rainfall forecast for their county warning areas. These products can and do emphasize different hydrologic issues depending on geographic area, land use, time of year, as well as other meteorological and non-meteorological factors. For example, during the early spring or late winter a flood warning can be issued for an ice jam that occurs on a river, while in the summer a flood warning will most likely be issued for excessive rainfall. In recent years the NWS has enhanced its dissemination of hydrologic information through the Advanced Hydrologic Prediction Service, more commonly referred to by the acronym. AHPS allows anyone to view near real-time observation and forecast data for rivers, lakes and streams. AHPS also enables the NWS to provide long-range probabilistic information which can be used for long-range planning decisions. Daily river forecasts are issued by the 13 river forecast centers using hydrologic models based on rainfall, soil characteristics, precipitation forecasts, and several other variables. The first such center was founded on September 23, 1946. Some RFCs, especially those in mountainous regions, also provide seasonal snowpack and peak flow forecasts. These forecasts are used by a wide range of users, including those in agriculture, hydroelectric dam operation, and water supply resources. Ocean Prediction Center. The National Weather Service Ocean Prediction Center in College Park, Maryland issues marine products for areas that are within the national waters of the United States. NWS National Centers or WFOs issue several marine products. Coastal Waters Forecast a text product issued by all coastal WFOs to explicitly state expected weather conditions within their marine forecast area of responsibility through day 5. Also addresses expect wave heights. Offshore Waters Forecast a text product that provides forecast and warning information to mariners who travel on the oceanic waters adjacent to the U.S. coastal waters through day 5. Issued by the Ocean Prediction Center. NAVTEX Forecast a text forecast issued by OPC designed to accommodate broadcast restrictions of the U.S. Coast Guard NAVTEX transmitters. The product is a combination of the CWF and OFF. High Seas Forecast a routine text product issued every 6 hours by OPC to provide warning and forecast information to mariners who travel on the oceanic waters. National Hurricane Center. The National Hurricane Center and the Central Pacific Hurricane Center, based in Miami, Florida and Honolulu, Hawaii, respectively, are responsible for monitoring tropical weather in the Atlantic, and Central and Eastern Pacific Ocean. In addition to routine outlooks and discussions, they initiate advisories and discussions on individual tropical cyclones, as needed. If a tropical cyclone threatens the United States or its territories, individual WFOs begin issuing statements detailing the expected local effects. The NHC and CPHC issue products including tropical cyclone advisories, forecasts, and formation predictions, and warnings for the areas in the Atlantic and parts of the Pacific. Climate Prediction Center. The Climate Prediction Center in College Park, Maryland is responsible for all of the NWS's climate-related forecasts. Their mission is to serve the public by assessing and forecasting the impacts of short-term climate variability, emphasizing enhanced risks of weather-related extreme events, for use in mitigating losses and maximizing economic gains. Their products cover timescales from a week to seasons, extending into the future as far as technically feasible, and cover the land, the ocean, and the atmosphere, extending into the stratosphere. Most of their products cover the contiguous U.S. and Alaska. Additionally, weather forecast offices issue daily and monthly climate reports for official climate stations within their area of responsibility. These generally include recorded highs, lows and other information. This information is considered preliminary until certified by the National Climatic Data Center. Data acquisition, surface observations. The primary network of surface weather observation stations in the United States is composed of automated surface observing systems. The ASOS program is a joint effort to the National Weather Service, the Federal Aviation Administration, and the Department of Defense. ASOS stations are designed to support weather forecast activities and aviation operations and, at the same time, support the needs of the meteorological, hydrological, and climatological research communities. ASOS was especially designed for the safety of the aviation community, therefore the sites are almost always located near airport runways. The system transmits routine hourly observations along with special observations when conditions exceed aviation weather thresholds. The basic weather elements observed are, sky condition, visibility, present weather, obstructions to vision, pressure, temperature, dew point, wind direction and speed, precipitation accumulation, and selected significant remarks. The coded observations are issued as METARs and look similar to this. METARKNX12115503018G29KT1/4 SM plus TSSNFGVV002M05 per meter 07A2957 or MK Park WND01029/1143 SLP026. SNINCR2/10RCRNRT2 set 6/74/010T10561067 11022 21056 55001 PWINOPNOFZRANO. Getting more information on the atmosphere, more frequently, and from more locations is the key to improving forecasts and warnings. Due to the large installation and operating costs associated with ASOS, the stations are widely spaced. Therefore, the Cooperative Observer Program network of approximately 11,000 mostly volunteer weather observers provides much of the meteorological and climatological data to the country. The program, which was established in 1890 under the Organic Act, currently has a twofold mission: provide observational meteorological data, usually consisting of daily maximum and minimum temperatures, snowfall, and 24-hour precipitation totals, required to define the climate of the United States and to help measure long-term climate changes. Provide observational meteorological data in near real time to support forecast, warning and other public service programs of the NWS. The National Weather Service also maintains connections with privately operated MESNet such as the Citizen Weather Observer Program for data collection, in part, through the Meteorological Assimilated Data Ingest System. Funding is also provided to the COCO-RAHS Volunteer Weather Observer Network through parent agency NOAA. Marine observations. NWS forecasters need frequent, high-quality marine observations to examine conditions for forecast preparation and to verify their forecasts after they are produced. These observations are especially critical to the output of numerical weather models because large water bodies have a profound impact on the weather. Other users rely on the observations and forecasts for commercial and recreational activities. To help meet these needs, the NWS's National Data Buoy Center in Hancock County, Mississippi operates a network of about 90 buoys and 60 land-based coastal observing systems. All stations measure wind speed, direction, and gust, barometric pressure, and air temperature. In addition, all buoy stations, and some CMAN stations, measure sea surface temperature and wave height and period. Conductivity and water current are measured at selected stations. All stations report hourly. Supplemental weather observations are required through the United States Voluntary Observing Ship Program. It is organized for the purpose of obtaining weather and oceanographic observations from transiting ships. An international program under World Meteorological Organization marine auspices, the VOS has 49 countries as participants. The United States program is the largest in the world, with nearly 1,000 vessels. Observations are taken by deck officers, coded in a special format known as the Ship Synoptic Code, and transmitted in real time to the NWS. They are then distributed on national and international circuits for use by meteorologists in weather forecasting, by oceanographers, ship routing services, fishermen, and many others. The observations are then forwarded for use by the National Climatic Data Center in Asheville, North Carolina. Upper air observations. Upper air weather data is essential for weather forecasting and research. The NWS operates 92 radiosonde locations in North America and 10 sites in the Caribbean. A small, expendable instrument package is suspended below a 2 meters wide balloon filled with hydrogen or helium, then released daily at or shortly after 11 UTC and 23 UTC. As the radiosonde rises at about 300 meters per minute, sensors on the radiosonde measure profiles of pressure, temperature, and relative humidity. These sensors are linked to a battery-powered radio transmitter that sends the sensor measurements to a ground receiver. By tracking the position of the radiosonde in flight, information on wind speed and direction aloft is also obtained. The flight can last longer than 2 hours, and during this time the radiosonde can ascend above 35 km and drift more than 200 km from the release point. When the balloon has expanded beyond its elastic limit and bursts, a small parachute slows the descent of the radiosonde, minimizing the danger to lives and property. Data obtained during the flights is coded and disseminated, at which point it can be plotted on a skew-T or STIG diagram for analysis. In recent years, the National Weather Service has begun incorporating data from AMDA in its numerical models. Event-driven products. The National Weather Service has developed a multi-tier concept for forecasting or alerting the public to all types of hazardous weather. These are: Outlook. A hazardous weather outlook is issued daily addressing potentially hazardous weather or hydrologic events that may occur in the next 7 days. The outlook will include information about potential severe thunderstorms, heavy rain or flooding, winter weather, extremes of heat or cold, etc. It is intended to provide information to those who need considerable lead time to prepare for the event. Other outlooks are issued on an event-driven basis, such as the flood potential outlook and severe weather outlook. Advisory. An advisory is issued when a hazardous weather or hydrologic event is occurring, imminent, or likely. Advisories are for less serious conditions than warnings, that cause significant inconvenience and if caution is not exercised, could lead to situations that may threaten life or property. Watch. A watch is used when the risk of a hazardous weather or hydrologic event has increased significantly, but its occurrence, location or timing is still uncertain. It is intended to provide enough lead time so those who need to set their plans in motion can do so. A watch means that hazardous weather is possible, but not imminent. People should have a plan of action in case a storm threatens and they should listen for later information and possible warnings, especially when planning travel or outdoor activities. Warning. A warning is issued when a hazardous weather or hydrologic event is occurring, imminent or likely. A warning means weather conditions pose a threat to life or property. People in the path of the storm need to take protective action. Special weather statement. A special weather statement is issued when something rare or unusual is occurring. These are usually triggered by sudden changes in meteorological conditions. The statements are to be taken as warnings for residents of a specific area, The warning generally states that an area might be at risk for a slight weather danger. Not all weather statements are warnings, though. Other times, statements describe informative facts about a weather system, such as local snowfall. Product dissemination, NOAA Weather Radio All Hazards, the voice of the National Weather Service, is a special radio system that transmits weather forecasts and alerts 24 hours a day across most of the United States. The system, owned and operated by the NWS, consists of more than 1,000 transmitters, covering all 50 states, adjacent coastal waters, Puerto Rico, the U.S. Virgin Islands, and the U.S. Pacific Territories of American Samoa, Guam and the Northern Mariana Islands. NWR requires a special radio receiver or scanner capable of picking up the signal. NWR stations broadcast on 7 allocated frequencies centered around 162 MHz in the VHF radio frequency band. In recent years, national emergency response agencies such as FEMA and the Department of Homeland Security have begun to take advantage of NWR's ability to efficiently reach a large portion of the U.S. population. When necessary, the system can also be used to broadcast civil, natural and technological emergency and disaster alerts and information, in addition to those related to weather, hence the addition of the phrasing all hazards. NOAA Weather Wire Service is a satellite data collection and dissemination system operated by the National Weather Service. Its purpose is to provide state and federal government, commercial users, media, and private citizens with timely delivery of meteorological, hydrological, climatological, and geophysical information. All products in the NWWS data stream are prioritized, with weather and hydrologic warnings receiving the highest priority. NWWS delivers severe weather and storm warnings to users in 10 seconds or less from the time they are issued, making it the fastest delivery system available. Products are broadcast to users via the AMC-4 satellite. EMWIN is the Emergency Managers Weather Information Network, a system designed to provide the emergency management community with access to a set of NWS warnings, watches, forecasts, and other products at no recurring cost. It can receive data via radio, internet, or a dedicated satellite dish, depending on the needs and capabilities of the user. The new Apport broadcast system provides a one-way broadcast communication of NOAA environmental data and information in near real-time to NOAA and external users. This broadcast service is implemented by a commercial provider of satellite communications utilizing C-band. The weather.gov website is a data-rich website operated by NWS that serves as a portal to hundreds of thousands of web pages and more than 300 different NWS websites. From the homepage, it is possible to enter a city and state to get a local forecast page, view a rapidly updated map of active watch and warnings, and select areas related to graphical forecasts, national maps, radar displays, rivers, air quality, satellite images and climate. Also offered are XML data feeds of active watch and warnings, ASOS observations and digital forecasts for 5x5 km grids. The Interactive Weather Information Network was an Internet site operated by the NWS that has been superseded by the weather.gov site. Since 1983, the NWS has provided external user access to U.S. government-obtained or derived weather information through a collection of data communication line services called the Family of Services. FOS is accessible via dedicated telecommunications access lines in the Washington, D.C. area. All FOS data services are driven by the NWS Telecommunication Gateway computer systems located at NWS headquarters in Silver Spring, MD. Users may obtain any of the individual services from NWS for a one-time connection charge and an annual user fee. Every NWS office operates its own web page with access to current products and other information specific to the local area. Technology. The WSR-88D Doppler weather radar system, also called NEXRAD, was developed by the NWS during the mid-1980s and fully deployed by the end of the 1990s. There are 158 such radar sites in the United States and selected overseas locations. This technology, because of its high resolution and ability to detect intra-cloud motions, is now the cornerstone of NWS severe weather warning operations. NWS meteorologists use an advanced information processing, display, and telecommunications system called AWIPS to complete their work. These workstations allow them to easily view a multitude of weather and hydrologic information, as well as compose and disseminate products. The NWS Environmental Modeling Center was one of the early users of the ESMF Common Modeling Infrastructure. The GFS system is one of the applications that is built on the framework. Organization: National Weather Service, Chief Information Officer, National Centers for Environmental Prediction, Aviation Weather Center, Climate Prediction Center, Environmental Modeling Center, Weather Prediction Center, Ocean Prediction Center, NCEP Central Operations, Space Weather Prediction Center, Storm Prediction Center, National Hurricane Center, Hurricane Specialist Unit, Tropical Analysis and Forecast Branch, Technical Support Branch. Chief Financial Officer, Operational Systems, Hydrologic Development, Science and Technology, Programs and Plans, Meteorological Development Laboratory. Climate, Water and Weather Services, 6 regions, 122 weather forecast offices, 21 center weather service units, 13 river forecast centers, Pacific Tsunami Warning Center, West Coast and Alaska Tsunami Warning Center. Spaceflight Meteorology Group. Failed Santorum proposal. While respected as one of the premier weather organizations in the world, the National Weather Service has been perceived by some conservatives as competing unfairly with the private sector. National Weather Service forecasts and data, being works of the federal government, are in the public domain and thus available to anyone for free in accordance with United States law. This was seen by some as hindering private sector meteorologists' ability to profit from weather forecasting. However, private sector meteorologists rely heavily on data generated by the National Weather Service, as no for-profit company has erected nationwide networks of weather radar or launched satellites. In 2005, Senator Rick Santorum introduced the National Weather Service Duties Act of 2005, a bill which would have prohibited the NWS from freely distributing weather data. The bill was widely criticized by users of the NWS's services, especially by emergency management officials, who rely on the NWS for information during situations such as fires, flooding, or severe weather. Groups such as the Aircraft Owners and Pilots Association condemned the bill's restrictions on weather forecasting as threatening the safety of air traffic, noting that 40% of all aviation accidents are at least partially weather-related. The bill attracted no co-sponsors, died in committee during the 2005 session, and no subsequent attempt has been made to restrict NWS forecasts. See also: NOAA's Environmental Real-Time Observation Network, Meteorological Service of Canada founded 1876, Reginald Fessenden known for proving the practicality of using a network of coastal radio stations to transmit weather information, National Weather Service Employees Organization, List of National Weather Service locations, references. External links: weather.gov, National Weather Service, Hydrometeorological Prediction Center, Aviation Weather Center, National Weather Service Employees Organization, Wind Map.